It's done the thing. Are there any software engineers here? I might get away with this. Has anyone had to work on any code that's really awful? Has any... I'm not going to pry into anyone's history. Has anyone had to work on any code that is awful when you look at it, but you suspect it might not have been that bad when it was first launched? The profession of software engineering is primarily concerned with change. So back in the beginning, there was machine code, and you would program it with punch cards or mechanical switches, and it was such a chore that people started using assembly code, which basically lets you use keywords. But it's still very much binary, directly translates. And when you do that, you have absolutely nothing that looks like writing in a modern language. C, I think the first iteration was 1965, and it introduced the main revolution that C brought us was it lets you define procedures that you can then call by name, and you can pass in parameters to it. So assembly language is what we call an imperative language. You execute a sequence of statements. C is still an imperative language, but it's also a subset of that called procedural. So it makes it much more readable. You can reuse code because you can define functions and call them back. You don't have anything that looks like what we use nowadays to access complex variables. Instead, what you have is pointers. And a pointer is just a memory address. So C has no classes. No classes, no methods. This is a struct, and what it is it's like a class, but all the fields are a known size in bytes. So if the first field of your struct is 4 bytes, and the second field is 4 bytes, and the third is 1 byte, then you have a pointer to your struct, and that's just an address, so it's just a number, and then you add 4 bytes to that, and then 4 bytes to get to the third address. So not super helpful. And when you define something like this in C, you allocate the memory yourself. You literally do a malloc call. So you need to know exactly what's going on in your memory. You want to create a string, you allocate enough memory for the size of the string, and then you increment byte by byte to add chars to it and then to get them back. And then if you forget to deallocate the memory at the end, you've got a memory leak. And nowadays, of course, we don't do that. We have references. We have references because we use languages like .NET or Java. And these have runtimes which handle all of this for us. You get a reference, and you never know exactly where in memory it is. And when you're done with your variable, you just drop the reference, and a garbage collector will go and clean the memory up for you. And this is made doubly useful because everything is scoped. Okay? So if you define a variable within a method, at the end of the method, that variable just ceases to exist, and you get the memory back, and you never even need to think about it. So it becomes a lot easier to program in higher level languages. But the real thing that Java and C# brought along, and they weren't the first, but they're object-oriented, of course. And in an object-oriented paradigm, you don't primarily write out each statement line by line. You instead define objects that have got behavior and state, and you set them interacting with each other. And this was obviously very revolutionary because in software, when you have a problem to solve, you need to somehow model the business problem that you're solving. Okay, you don't get paid to write software in order to just add two numbers together. You've got to it might be a payroll software. You've got to think about bank accounts and employees. And when you have objects, it literally enables you to think your programming at about the same level that you're describing the thing that you're trying to solve. So object-oriented programming became absolutely the dominant paradigm. for business software. And the other thing that object-oriented programming brings is access modifiers. Okay. Now, an access modifier means that anything in an object can be declared public or private. It's no business of anyone else's what the businessman chooses to spend his money on, even if it's not a traditionally masculine toy. It's reduced to 1999. He's still got his Christmas money to spend. His Aunt Jean specifically told him he could spend it on whatever he wanted. But it doesn't interfere with him doing the finance stuff. And if you are interacting with a businessman, all you really care about is, can he do the finance stuff? Can he attend meetings? And is he wearing a business suit? Okay, the rest of that is hidden. And that means, of course, he can change his mind and get rid of My Little Ponies and decide he's all in on Furbies. And if you can keep these things hidden, then the internal mechanism is hidden. Anything you make public effectively forms an interface. And I'm not using the exact term that C# and Java developers will mean, but more generally, an interface is the set of public stuff that other users can see, or other classes. And an interface is a bit like a contract. Okay? If you have something public, you say, I will do these things if you only touch the public stuff. And the flip side of that is, of course, if someone goes rooting in your private members and they get burned and their code breaks, it's their fault, okay? That's internal mechanism. They might jam their fingers in it, but that's why you don't want to do it. You want to stick to the public interface. And these interfaces are really key, because if you define what consumers of your code can do with it, you make that an interface. And if you think carefully about the interfaces you design, then the code kind of designs itself, okay? And you don't need to get bogged down in every minute detail. It's all about the interfaces. Now, in Java and C#, interfaces are first-class citizens and have their own keyword. In PowerShell, this really more applies to when you write a function, the return type of the function, what you get back from it, the parameter block. If you have a module, it's what you export from it. What else have I written? To a lesser extent, if you're writing classes in PowerShell, what you write is hidden. But what I'm trying to get across is, it's a good principle to follow, to take great care over what you expose from the code you write, and only expose the public stuff that you actually want to support. Okay. I'm not going to go into these too much, but while I'm doing a history lesson, honorable mention for declarative languages. In these ones, you don't write sequences of statements. You just set up data and then feed it into a machine and set it going. And a subset of that is functional programming, which probably JavaScript should be on this list. But in these, imagine starting with YAML, but you also define the operations that work on it. But it's kind of, rather than sequences of statements, it's set going from the beginning. But it's completely tangential. Let's go no further into that. I've closed my notes, bastard. Humour me. Pretty sure we're under the code now. Polymorphism. Okay, right. I need 2 volunteers. Chris. Oh, sit down. I don't need you to stand up. And another one. Right. Please hang on to the end of that. Please hang on to the end of that. Okay, you are a cow. You are a sheep. When I pull your string, you make your noise. Thank you very much. Thank you very much. You can let go now. What just happened? I pull on the end of the string and I get a noise. But at some point, we made the decision about what noise we were going to get when we chose where to put the other end of the string. But it's the thing on the other end of the string that implements the noise. Okay? I didn't have to go, if I'm pulling the right-hand string, then make a cow noise. I don't need to keep track of that. It's what's on the other end of the string that tells me what kind of thing I'm going to get when I pull it. That's polymorphism. So coming on to PowerShell. Technically, it's object-oriented. It's OOP. But really, we use it in a procedural way. You can argue it's a functional language because functions are objects, but that's it's not really the case, is it? We write functions and we pass data into them, just like in C. So we can use it as an OOP language. There's more than just PowerShell classes to define classes. You can create PS custom objects and get a lot of the same functionality. You can strongly type a variable, but you're not going to get the help from the compiler. Okay, there's no compile phase that's going to go, oh, you can't even compile this code. If you declare something as a string and then try and assign a WMI object to it, you're going to find out at runtime. But it's still better than nothing. So it's a little bit fuzzy. Design patterns and the study of software engineering not a lot has been written, okay? People who are writing apps significant enough to want to apply a real methodology to it are probably not writing in PowerShell. And there's a reason for that. If you want to write a complex piece of software, the strong typing, the compile time checking, all the rigidity of C# is a massive help. But PowerShell works for all of us, right? Okay. One of the major arguments you can make in favor of choosing a language that you're going to write an application in or anything is, do you have the skills in the team to support it? And here we all are. We all use PowerShell, so we are going to be writing stuff in PowerShell. So this talk is really a bit of a talk about how we can shoehorn stuff in, and it's going to be a little bit hacky, and you can pick and choose what you want from it. So, software engineering is primarily concerned with change. You have new acquisitions, okay, regulatory change, new business processes, new apps, new providers. We should take trouble to write software that's evolvable. Okay, we want to write software that can be changed and not just kind of changed at random like potato masher, just keep changing it. No, we want it to be able to change in a directed way such that it continues to meet the needs of the business and continues to have an architecture. We want it to start out with a design and still have a design after a few years, even if that design isn't necessarily exactly the same. If we do not concern ourselves with the practice of software engineering, and this may not apply, okay, if you're writing 200-line scripts, but if it starts getting a bit more complex and when we don't think about software engineering, we're in danger of writing spaghetti code. And that's when change becomes difficult, expensive, and demoralizing. Design patterns are strictly a conceptual thing, okay? Design patterns aren't pieces of code that you find written in a language. It's the observation that if you see a lot of software, you'll notice that there are certain kind of problems that you can abstract out, and there are certain generalized solutions that may or may not be a good fit for those ones. So it's kind of picking and choosing from a mental library of kind of what type of solution you can apply. So I don't know if you guys thought you were going to get away without a code demo. But the problem I'm going to talk about is PSD1s and required modules in PowerShell modules. So you guys all recognize this is a module manifest .psd1, right? Oh. This is going to be a problem. I'm going to have to. Boom. Okay, can we get through the rest of that like that? That'll do. Okay, we're looking at a module PSD1. And the bit that we care about for the purposes of this talk are the required modules field. Yep. I don't know, can I? There we go. It's just my laptop. It tries hard, bless it. How's that? Can everyone see? Okay. That's probably... Look, I'll go bigger if you guys want. No? Okay, good. Required modules. You can specify something in here, and if autoload works and the module isn't already loaded, autoload is going to try and find that module. If it cannot find it, or if you're in PowerShell 2 or autoload is turned off and the module isn't loaded, it's just not going to load your module at all. These are the dependencies, okay? And you can specify in a mixed array to the required modules field. You can have a string, or you can have a hash table. And if it's a hash table, it has to have a name, it can have a GUID, and it has to have one of module version, required version, or some other stuff that I don't think we need to go into. So that's the problem. My team distributes its code through GitHub releases. Okay, our Jenkins goes and builds stuff, creates a release. The code's available there. And so we've got a whole bunch of modules that... one of the problems we have to solve is if someone says they want a module, they also need the dependencies. So we end up with a solution a bit like this. This is sample code, okay? This is not actual code from our company. It's a recursive function. You want a module, you give it the name, the version. We do some stuff involving branches sometimes, otherwise it's token for the GitHub. And what we want to do here is, you guys get that order is important when you're importing the dependencies. If foo requires bar, then you need to import your modules in the order bar foo, right? Okay, so this is a function that is going to download to wherever. It's going to do two things: download the module from GitHub and give you a reversed import list so that you can import the dependencies first. So we create an import order. We do something, whether or not it's a branch, go and hit GitHub, do a GitHub thing, get the module. Download that module, look at the PSD1, parse it, and then we're going to have a look at the required modules in the PSD1. And we're going to call the function recursively. So not too complex. And then we're kind of adding to the import order. So then our finance team figures out that we're using a lot of GitHub licenses. and they start saying, okay, well, now we're going to have a policy that if you don't touch GitHub for 30 days, then you're going to be removed from the GitHub license users. And this affects all the desktop users who use our code. So suddenly we've got to move to NuGet. And when we think about that project, we have a look at this, and this is the kind of code we've got. And it touches GitHub on every line. This is a simple version. This is a simple version. The real function's like 400 lines. It touches GitHub deeply throughout, okay? And then you have a look at the param block, and it's asking for things like tokens and branches. So the param block is completely oriented to GitHub. So not only do we have to change this function, but we've got to go and change all the calling code. And that's not even the end of it, because this is an implementation that's used in the service layer of our flagship app. But we also use it in Jenkins, okay? We use it in a build pipeline, and we've got a separate function there. And we've got a kind of homebrew package manager as well that kind of goes and hits GitHub for our users. And the same functions in there as well. So this brings us to our next principle. Don't repeat yourself. Okay, so the problem we've got in terms of GitHub being really bound into the other problem, the next principle we've got is we want to separate out bits of code that do different things. Each chunk of code, each module, each object, each class should only do one thing. And what our problem consists of mostly is the data structure about module dependencies and the GitHub bit. So we're going to have a go at separating those out. When you have module dependencies, okay, a module might be required by another module. If it's the first one you actually care about importing, it's not required by anything. But it might have more than one things that it depends on. So we've got a tree structure. Okay. And how do we implement a tree? Not bad. A tree it's made up of nodes, and every node is the same. And a node it's got to have a parent and one or more children. So this is a basic implementation for a tree. Okay, the class is node, the type of the parent is node, and we have 0, 1, or many children that are also node. And I've written this crappy little visualization thing that we're going to keep using so that as we develop, we can see what we're doing. Okay, we've got a public print tree here. Doesn't take anything, but all it does is it calls the recursive internal function, creates a variable and calls the internal recursive function _print tree, which is going to go through all the children and increase the indentation each time. So really, really elementary implementation of tree structure. Yes, okay, some simple test code, create a node, add some children. And yay, it prints out a little tree, which is what we expected to happen. But that doesn't tell us very much about a module. So we're going to need to inherit from something that's actually a bit more useful. And the class I've chosen for that is module specification. Module specification is something you get for free with PowerShell. Here's the source code. We have constructors that take a default constructor, a constructor that takes a string, a constructor that takes a hash table, and a constructor that takes a PS module info. Does that remind you guys of anything? Back here in the required, we can give it either a string or a hash table. it turns out that the PowerShell engine, when you open a module manifest, under the hood is converting this required modules field into module specification objects. So this seems like really closely aligned to the problem we're trying to solve. So we're going to take that module specification class and extend it such that we can turn it into a tree. And I decided to call it module spec. So in PowerShell syntax, this colon means we're extending it. It's in Microsoft PowerShell commands, so I'm using that so I don't have to type it every time. And we have module spec class. We give it a constructor that takes a string, and we pass the string straight onto the base constructor. So all I'm doing here is I'm just passing the buck on to the constructor that already exists that we just saw in the C# code. Same with hash table, same with PS module info. And because we're inheriting, we get this stuff for free, okay? This is all the stuff that makes it relevant to the problem we're solving. And this bit we've already seen. We've got a parent and we've got a collection of children. And this print tree function we've already seen. So let's have a look at it. Works. A really crappy mock function to create a couple of these and set them as each other's parents and children. Okay. And we can see that we're trying to import roof. Roof depends on walls, walls depends on the foundation. So we've got the kind of the sketch out of a solution. So that gives us our tree. We'll work a little bit on writing something that'll go and fetch modules for us. Module spec is unchanged. We're leaving that alone. And I've sketched out a class. This is completely from scratch, okay? And this class has only one module, one method, which is get module. And it's going to give us back a PS module info. Because when I was mucking about with this stuff, I thought, okay, this is going to be something related to import module, so it's going to give you back the same thing. It takes a module specification, so we are going to say, okay, we've got a module spec like we had in required modules in PSD1. Go and get me the module. And this is just a mock function, okay? Creates a new empty module. Some crap in here to give it required modules, okay? This is mock code, and it looks for, is the module called roof or walls or foundation, and then sends it back. And that means that our function looks a bit like this. We now take a parameter, we take a module spec. So we're going to call this function and give it something. We create a fetcher object, and we get back the PS module info of the node. This parameter that we accept, we're going to return it as well. But before we return it, we're going to go and flesh it out and turn it into a tree structure. So we've got the PS module info back, and we're going to iterate over with the for each method, iterate over each required module, and do that kind of tree thing in a recursive function with the call to itself there, just on the child node this time. And we get the same output, which is relieving. Ooh. Something that's nice about this solution so far is that we didn't change module spec since we wrote module fetcher. If we have a look at module fetcher, there's no mention of module spec anywhere in it. Okay, it does depend on module specification, the PowerShell class, but it doesn't know about module spec at all. It is very loosely coupled to the two things. And the idea behind this principle is if you have two separate classes, and this class touches this property and this method and this field and this delegate, and this class touches all these things here, you have a lot of interaction between the classes. They are tightly coupled. And that's a pig because anytime you want to change something, you've also got to change the other thing. what you really want is a class to only touch one or two methods of another class, or one or two properties. So at the moment we've got a very loose coupling, okay? They're basically not aware of each other. So, okay, got some mock functionality, but we want to now do something a bit more useful. I'm not going to go straight to GitHub. I'm going to pick up modules from the file system. Bear with me. You'll see how this shows the way forward. So I've got some mock modules here, and imagine this is your PS home or something. I've got a bunch of modules here. Human is the one we care about. That's at version 1. And it requires cow, pig, and cabbage, version 1s of each of those. Okay. So to keep the functionality the same, this is our module fetcher from the last commit. The only difference is I've renamed it to mock module fetcher, and I've made it inherit from module fetcher, which now doesn't exist. I'm about to show it to you. All the rest of this code is exactly the same, just renamed it. So I've created a new class that's going to be a base class. And this is what the class looks like. A bit more screen size. Okay, if we have a look at this class, how can we create an instance of this class? It is a trick question. You probably can't see from there, but there is only one constructor defined. There's only one constructor defined. And it's going to throw an error. Okay, we cannot create a new instance of this class. It's a base class that exists solely for the purpose of being a base class. It has got the same module, the same get module, takes a module spec, returns a PS module info, same method signature, okay? That's also going to throw. This is a class that we cannot instantiate. We're going to create a variable of the type of this class. This class defines an interface, okay? When you get a class of this type, you know that you get a method called getModule. And when we declare a variable, it's like we've got a string going to something that connects to this method, and we can say, okay, we know at the other end of the string, we've got something that will give us a PS module info if we pass it a module spec. That's guaranteed by the contract. But we can't have one of these type. Our reference says module fetcher, but what we're actually going to have at the other end of the string is going to be a mock module fetcher, or a file system module fetcher. And this is completely different, but still inherits. This guy here has got the concept of a module path. Okay, when you've got one of these, it's got a place on the disk that it's going to look. And when you ask it to get you a module, it's searching that path. And it's just going to use the PowerShell get module. Okay, it's just going to list available. And it's going to grab whatever it can find that meets that module spec. Right, it's got to have the right name. And then return that, or throw. So completely different implementation. Same method name, same method signature. So now our function to build the tree looks like this. Okay, we have got an if-else. On one hand, you get the mock module. On the other hand, you get the module from the file system. And we've got a switch here. And when I call this function, I can give it that switch. And it'll say, okay, now I've made the function search in a particular place. I've still defined the fetcher variable as a module fetcher. But either of these guys can fit in that variable because they are module fetchers. They inherit from it. And then when I call the actual get module, okay, which behavior I get depends on what we decided further along. Okay, I am doing an if-else, but I'm only doing it up here at the top. I'm not doing endless if-else throughout my code. I'm not going if we called it from this, then go to GitHub, otherwise go to NuGet, otherwise go to file system, because that way you end up with like 4,000 lines. And this is exactly the same, okay? This little section here, exactly the same. The module call, exactly the same. Does it work? Bear in mind we are in a live demo. Okay, so that's still with the mock code. Yay! We've got a module tree here, human at the top, and then it's calling the other things that those things eat. So we've switched it just with a switch, and we swapped out one object for another, but they can both fit in the same variable because they're both the same base type. Have I done the next slide yet? This is called the Liskov substitution principle, or polymorphism. Okay, you can there's ways to make it so that you can swap objects between each other in a clean way. You just need to make sure they all obey the same interface, the same contract. Have I got ahead of myself? Slightly. I have. No worries. What we've done here, the function, the getModule dependency function, is essentially just a framework for swapping in a module fetcher. And this is an example of what we call the strategy pattern. And the strategy pattern is when the behavior of one object doesn't come from something hard-coded in the object, but you give it another class, the way we've just seen. Okay. And you guys see that we can quite easily extend that to do NuGet and GitHub as well. But there is a problem with what we've written here. What happens next? We want to add GitHub functionality. So we're going to write another else block here, and we're going to have some code here that defines a GitHub module fetcher. And we're going to add another switch that says, okay, yeah, we're going to end up with parameter sets up here. I don't know if you guys noticed, but we've just got a magic string here. I've just told the file system fetcher where it's searching. But realistically, that should probably be parameterized. So we're going to end up with an unmanageable parameter block up here. And we're going to end up with a very long function body down here. And really, that's all wrong, because when we change the param block, we're going to have to go and change all the calling code, and all of that is broken. So we are going to move the dependency creation out of this function. And that's called dependency injection. When you call a function, your interactive terminal can be thought of as the client of that function, okay? Or if you start a program at the top level of your program, you're in a way at a higher level than the stuff you're calling. Now, the way we had previously written that function, the control was with the function of what kind of fetcher we had, which is all the wrong way around, okay? We want something like that to be defined right at the top of our code. We want the control to be back up at the top. So we're going to create that fetcher outside the function and pass it in. And that's going to be dependency injection through the param block. But we could do it another way as well, right? Because this function's likely going to be within a module. And modules have got their own scope, and you can have a module variable. So you can do a dependency injection in more than just one way. But in PowerShell, a parameter block is a really obvious and straightforward way to do it. So what did I say I was going to show you first? The function itself. Here we go. We've defined module fetcher. So this is the base class. We can pass it anything that inherits from that base class. Ultra simple. How simple is that? And this is what the code looks like. Creating a fetcher, okay? Just got my code out here at the top, and you can imagine starting a function. What's the first thing you do at the top of a program? Configure and initialize, right? You go, okay, I'm going to set up logging here and maybe create some magic strings. So it's no stretch of the imagination at all to go, okay, if you've got a 4,000 line program, one of the things you do at the top is you go, okay, we keep our modules in GitHub, or we keep our modules in this location on the file system. And it still works. And we've still got the option of doing the mock module as well, okay? I don't think I changed anything else in these bad boys. Right. Right, yes, I did. Let's make this code do something useful and actually import these modules. Okay, so at the moment we don't have any way of getting a list out of the tree. So let's go back to module spec. And I have created get import order. Same pattern as the print tree. Okay, this one is a public method that has no parameters. And you hit that up and it just creates a variable that's going to be needed by the recursive function and then calls the recursive function, which we've hidden. Because PowerShell doesn't give you the private access modifier, this is just a way of saying, please don't use this. Okay, recursively go and do this, take the list, add yourself to it, and hand back the import order. So we should be able to run this, yes. Might need to kill this because we've got old class versions. Okay, we get a list, and grass is required by cow, and truffle is required by pig, and cabbage is required by human. This is correct. So let's see if we can import them. No, we can't. And the reason is we haven't done anything that touches versions. Okay, it turns out that actually if we go into our modules, this is the problem we've got. We require version 2 there, but we've only got version 1. So it is not easy zoomed in this much. That'll fix that. But we're going to need to create an is met by. Module spec, right. Is here. Is met by any node on the tree. PS module info represents an actual module you've loaded. Module specification represents what you need when you want to load a module. So we pass in, we say, is this actual module meeting a specification of a specification? And there's a bunch of logic here. We know we've always got a name. If there is a GUID, the GUID's got to match. If there is a version, the version is going to be greater than or equal. If it's a pinned version, it's got to be exactly equal. And then back in the fetcher, we had a for each, didn't we? And it was just a true, just get me the first one that matches. And now we're calling the is met by instead. And the thing that's a slight shame about this, the thing that's a slight shame is that now we've got a reference to module spec. Okay, so we've increased the coupling between these two classes. There was none. Now we actually have to build it in a certain order, and we've got to have the right using here. The using statement, we've got to load the classes, and we can't now change this so easily. Okay, so my team uses exact version pinning. If you put a version in, if you require 161 of something, we will only allow you to go ahead and run that code if you've got exactly 161. 165 isn't going to do the job. If we ever wanted to change that, that would be implemented in the isMetBy method. How could we change that? How could we change the software so that that change becomes easy? We can do exactly the same thing, right? We can do exactly the same thing. We can make the isMetBy behavior a strategy object. And we can have an exact version pinning strategy, or we can have a loose version pinning strategy, and we can swap them in and out of the module fetcher, because it's the fetcher that's doing the comparison. And in fact, in C#, sometimes you can supply string comparison objects. When you're doing anything that does string comparison, some of them have got culture sensitive, accent sensitive, and these are objects that you can pass in to the method that's doing the comparison. But it would be insane to do that, okay? Because we are not going to change from exact version pinning, okay? So I didn't write the code. This is another useful principle, okay? In this code demo, for the purposes of having a demo, I'm being quite structured about, frankly, a little function to go and hit GitHub. But something to keep in mind is don't just go absolutely crazy with everything. Don't throw everything in, okay? Because a lot of the problems that you might want to generalize for are problems that belong to a tomorrow that may never come. And then you end up with too much complexity too soon in the wrong way. So there's a certain amount of judgment. If you do later find out that you do need to change that thing, that's when you do refactoring. And refactoring is something to do regularly. Refactoring is, you might strictly be required to change one thing in order to achieve one certain outcome. But while you're making that change, you realize, well, okay, there's another function and I need some code that's already in that function. Okay, we've got some duplicated code. So I'm going to pull that out and reorganize it and put that in another private function. Just kind of keep tidying it up so that you don't have duplicated code. Or in this case, you might go, well, now this method is not really still the best way to do it. So I'm going to stick in an object that represents that behavior. Keep it going tidy. What we're doing here in this demo is a really big refactor. We're essentially rewriting from scratch. But you can do little small things to keep your code tidy as you go along. And that is exactly what makes people happy with you years down the line. The point with refactoring is you want the code to still give the same output, but it's going to be so much easier to look at. So I am not going to implement a GitHub module fetcher or a NuGet module fetcher for you here, right, guys? Okay, I've shown you we can extend the base class. We can put any functionality we want as long as we've got that method. So it's kind of not really within scope. But there is one more thing I do want to do in this walkthrough. I do not like that the module spec tree is doing its own formatting. Okay, that's doing two things. It shouldn't be doing two things. It should be doing only one. So we're going to separate the concerns. We're going to separate the concerns, and we're going to have a PS1 XML to do the formatting. And I don't know if you guys have used a PS1 XML before, but this is an ultra simple one. It says that module spec type objects get formatted as a table, and we by default show the name, the version, and the GUID. And what's interesting in this PS1 XML is that although version and GUID are straight property names, under the label name, we've actually got a script block. And this script block is going to apply a level of indentation according to how deep in the module tree that particular module item is. You guys know you can multiply strings by ints, right? If you have a string, you multiply it by 8 if the string repeats 8 times. So we're going to write a getGeneration function that's going to return 0 for the module at the top level, 1 for the next one, then 2, then 3. It could have been called getLevel. And this is the same pattern as before. There's a public version and a private. So this is going to be 0 for some and then 1, 2, 3. Because we've got that, we can delete all the print tree crap, okay? We can delete all that. And because we're now using default PowerShell formatting, what we want to get back is a collection of objects. So we're going to have a toList method. We just want to get all these things back as a list and just let PowerShell format them the way it normally does a collection. And that works exactly the same way getImportOrder did. The only difference is that now it's in the right order list instead of the wrong order list. So we've changed the order in which it outputs. And because we've now got that, getImportOrder has got duplicated code. So we get rid of that and make it call the toList. So there's only one section of code where it's doing that, and then we just reverse that. So we've got rid of code that doesn't matter. We've got rid of code that doesn't matter. We've got rid of duplicated code. It's a refactoring. Come back, terminal. No, go away, terminal. I believe this is going to work first time. So it hasn't started yet. Yay! Okay, look, completely different output. It's clearly running through a default formatter, and it's given us our thing. And oh yeah, I haven't shown you whether or not the import module actually works as well. So let's just do that for the sake of science. No errors. No errors. And look, there are our modules. So, shit, demo worked. That is the end of the code walkthrough. No errors. No errors in the live demo. So to recap, we thought about what kind of change we might have to support. We came up with an architecture that was going to support that change. We separated out all the things that each different problem component did. We used the strategy pattern so that the thing that changed is encapsulated, okay? It's only changing in one particular area. And we injected that in so that it doesn't even need any code change low down in the weeds of the code, okay? We've moved all that change up into a line at the top of our code. We've given our tree structure some methods to do everything that the tree is going to need. So now we can take that, and the other place we're also doing this kind of thing, okay? In our Jenkins, we can now use the same object there. We know what we're going to do if we want to move to GitHub or if we want to move to NuGet. We've given ourselves the freedom to make that change. It's not wild freedom, okay? We haven't made it easy to turn a module into a bar of soap, okay? This isn't going to be any easier to make it count mangoes or something. But for the thing that we think we're going to want to change, we can now change it quite easily. And there was something else I remembered at the last minute I was going to say, but I've forgotten it. Okay, how are we doing for time? It's 8:15. Patience still good? Okay, this is 2 design patterns I've shown you. Design patterns, the phrase design pattern comes from architecture in like the early 20th century or something, but it was first described by the gang of 4 academic software engineers who wrote a book in 1994 in which they described 29 design patterns in OOP. And since then, it really took off. And the design patterns they came up with were really very general, but it's become a significant area of study. And now you can get people who will say, oh yeah, there are over 100. And they're less atomic and more focused on the problems that we have nowadays. So exactly what a design pattern is what your set of design patterns is to choose from is a matter of argument. Okay, some people call the same thing different names, and some people argue over whether 2 things are actually distinct patterns. So I've just picked another 5 to rattle through with you. No more code, not really any more code. Okay, adapter. You use Tivoli to store all your fleet. Okay, you've got a whole bunch of devices in there with credentials, IP addresses, monitoring configs, stock keeping units, all that crap. Your boss catches on that ServiceNow is cheaper. So of course you've got to move to ServiceNow in a month. Okay. Now you've been using Tivoli for years and you've got a lot of code that uses Tivoli and it all expects an IP address to be IP underscore address, and now suddenly you've got a new product coming in that's going to be IP no underscore address. Okay, fundamentally your old code is incompatible with the new thing that's come in. An adapter, what you're probably going to write is a convert to Tivoli format, isn't it? It's going to be a function that just takes whatever that thing is and it creates a new object that instead of IP no underscore address, it's now called IP underscore address. And you might do that with alias properties. Okay, you might just take that thing in and just add member alias property. Or you might create a new custom object and manually create all the properties and have the old object as a property inside it, perhaps. There's a million ways you can do it. But if you have got an object and something that requires a particular interface and they are incompatible and aren't going to work together, know how, an adapter is when you write some kind of little wrapper that translates. And there's another thing here that you would not be able to do in C#. Okay, let us pretend that you have got a function here. Let's say you've got a function here and I don't care what it does. I've called it install MSU. But it requires, for whatever reason, it requires the full path of a file. And you want to get the files using getChildItem. I've just limited it to 5. Okay. You want to get the files with getChildItem. And I don't know if you guys have ever tried this, but we've got a parameter type here of string. And if you send, when you getChildItem gives you file system info type. And if you cast those to string, you don't get the full path, you get the short, just the file name. So if you do that, then you have to loop over and you have to do something in order to manually get the .fullname property. And that's fine, it's not really super expensive. But PowerShell gives you this thing called aliases. And if we alias to full name, and also the crucial thing is that we're accepting values by property name as well as just from the pipeline, then we've adapted the interface, I would argue, missing a C. Nah. I've jinxed it, haven't I? Okay, look, it's going to work. It's going to work. Brilliant. Yay. Okay. Is it an example of the adapter pattern? Probably not strictly. It certainly wasn't what the Gang of Four had in mind when they described an OOP world, but it is adapting. Similar to adapter. This one's also about wrapping objects, but the difference is that when you use an adapter, it's because you've got an incompatibility and you've got to make one interface conform to another. A facade is really all about convenience. If you have a module where the purpose of the module is to go and hit an API, that's quite arguably a remote facade, because if you didn't have that module, every line of code you wrote would have to go and do a web request. It's much simpler to just call a function method, let it handle all that and get an object back. Yes, the reason I wrote this, I don't think I've ever written a facade other than an API client, which is arguable. I don't think I've ever written one. But I wanted to bring this up because PowerShell is absolutely silly with the things. Okay, PowerShell, the main strength is it's a good programming language, but the main strength is it's incredibly empowering for systems administration. So, okay, get service. goes and hits the service controller. Get process. Again, it's going to the Win32 native API. And in both these cases, what you're getting back is PowerShell objects that are incredibly convenient to use. You can do all this kind of stuff with them. And the net adapter command, that's anything to do with networking. That is a facade for a WMI call. Okay, PowerShell gets loads and loads of facades in order to let you sit in the middle and go and hit all those APIs, all those different ways of getting data from a system, and use a unified and consistent way to do it. So that's something you won't write, but PowerShell does lots of it. This is my favorite. I've written loads of proxies. A proxy is when you have a placeholder that matches, okay? And in the context of PowerShell, this almost invariably means a command. So you take a command, you create a proxy for it, and then it looks a lot like you're calling the original command, but actually you're hitting the proxy and you can do other stuff. You can inject things. In my example, which I won't dive into too deep, okay? This is all in GitHub. You can come back to this later, but PowerShell will let you create a proxy. It will automatically create a proxy for you. I'm proxying import module, and in this, I'm giving it the same name. You don't have to. This section here, okay, this is what the parameters for import module actually look like. That's literally them exactly in code, okay? And I take all those and do them exactly as they are in the original command and add one of our own. Okay, so this is a proxy that's going to add a little bit of functionality. It's going to let us import a module in God mode. We strip out the extra thing we've added so that we can go and call the original module, which I do by fully qualifying the name. Okay, we're either piping or we're not, so we're adding pass-through. This does the original thing. Okay, that's the proxy command. And then we do this special thing, which you can look at later if you're interested, and you have a look on the Meetup page and grab the URL. And then we pass it back through. So that's an implementation of a proxy. Let me show you quickly what it does. Oop, oop, oop. Okay. We're importing posh RS job just because I happen to have it and it happen to have private functions, and it gives us 6. There are 6 commands exported from posh RS job. Now I'm going to import it again. No, yes, oh, because I haven't run F5. Now there are 18. Okay, I've added a switch that also exports all the private functions. Now that is arguably not a proxy, an implementation of the proxy pattern. It's arguably a decorator, but I don't care. Okay, there are people who literally argue about it academically. My team's flagship app lets us run scripts from a library on customer devices. And the scripts are PowerShell scripts. Okay, they have param blocks, they have names, and they give you output. And the CLI tool that we've got for it takes all these and parses them using basically similar stuff to you've just seen there, and creates proxy commands for them locally. So you can come along, you can load the CLI module, and you can go whatever it is, get last SQL error, and you can supply all the parameters that you would, just as if you were running it locally. And apart from the fact that it then takes the time, there's a lag while it goes off and goes through all the PCI stuff, comes back, it's just like running the same thing locally, okay? That's a specific case of a proxy called a remote proxy. Super useful.
Isn't that what they use in PowerShell core for calling? So they use PowerShell remoting. No. So commands that don't natively run in PowerShell core, they do a remoting session to the host on itself to call into Windows PowerShell to all the stuff.
If that is the case, then yes, it is. But my question would be, what is the proxy in that case? Because is it a command where you've got a command that's a proxy, or is it more like the entire session? Without having had a look.
Yeah, no. So take for argument's sake, exchange commandlets, for instance.
Yes,
So
and in those ones,
like a get mailbox, I don't think it's natively supported in .NET Core. They then, when you import that module, the
yeah,
got like a proxy module, haven't they, for all of
yeah, yeah, and when you connect to O365, you get session imported, don't you?
Yeah, but this
All
is
the
different.
commandlets that
So
are
this
available in
is
session.
for native Windows PowerShell commandlets that don't run in PowerShell Core.
Okay.
You import the module and it creates a load of proxy commands that when you type them, it does a remoting session to itself into Windows PowerShell to run them and returns the objects back to PowerShell Core.
The best answer I can give you is it sounds like it. I'm not familiar with the tech you're talking about. I still support PowerShell too. Oh, I wish I could believe you. Right, what have we got next? Iterator. This might take a while. Might skip this one. Decorator. Okay. I'm not going to show you any code because this is not something that's particularly easy to implement in PowerShell. It's arguable that what I just did with adding the God mode switch to import module is decorator. The idea of a decorator is that you wrap something with something else that looks the same as it, same interface, same methods if it's an object, same param block and return type if it's a function, but it does something that changes it on the way through. And I bring this up because Python makes this incredibly easy, okay? Any of you guys use Python, yep, you will know exactly how to do decorators in that. It isn't something where I could knock up some code in 20 minutes for this in PowerShell. Oh, I thought of a way forward. I showed you the commands that will generate proxy commands for you. And that comes out with a begin, a process, and an end block. So the begin, process, and end are always going to be the same. So you can use them to do a regex snip and add a line of code at the start of the begin block. So you could make a logging decorator.
Would you not say that advanced parameterization was like a decorator? It's the same functionality as it does in Python.
When you say advanced parameterization,
So when you,
parameter sets?
no, you know what I mean. Clearly don't. So when we went from 2 to 3 and you had all of a sudden you could start, what the hell is it called? Where it adds in verbose and debug commandlets and all that.
Oh yeah. Oh yeah, yeah. Okay, yeah. So you get a whole bunch of parameters for free.
Yeah, but a whole bunch of functions as well for free, don't you? That's it. That's the phrase.
Yes, it's got a lot that makes it look like a decorator.
So I mean, when I'm using decorators in Python, I'm generally using them to get logging functions.
Yeah, it's kind of the same idea, isn't it?
Yeah.
The difference in Python is you can just do it with essentially an @ sign and something, and you can define that particular decorator elsewhere. I haven't yet found anything in PowerShell that makes it as elegant. But yes, if you said, Freddie, go and figure out a way to dynamically turn all of these things into things that log as their first line, I would probably do something where the end result looks like a decorator. But the way to get there is such a hack that I'm not sure if it would technically count as the design pattern, because it's just so kind of almost an anti-pattern if you're using regex to dynamically update functions. One more thing. Oh. Compound pattern. Okay, I've shown you, let's say we've got a GitHub fetcher and a NuGet fetcher, but we can still only pick one. Okay, we have a defined interface, but we've only got a method to be one or the other. We've got no kind of coexistence scenario. What happens if we want to check NuGet first, and if that returns nothing, then check GitHub? Well, for that you would use a compound, which is an object that has two fetchers inside it, or one or more. Okay, and you give that compound object both the fetchers you want, or all 5 of them, And that compound object has got a get module. And it also has an algorithm inside it that goes, okay, someone called my module, I'll call the module on this first GitHub fetcher. Oh, did that fail? Okay, I will move on to the next one and try that. Oh, did that fail? Okay, move on to the next one. Now, the object that's got the compound object doesn't know, because it still inherits from the same class and it's still got the right method signature. But that's a way to have, like a strategy, you're swapping things in and out at runtime. But super useful in the context of if you ever have to implement a strategy pattern like this. Let's go to the pub. Seriously, the one last thing I want to say is don't ever be too rigid about applying any of these rules. Okay, there are going to be times when the code won't work if you're too rigid about it. Just kind of take it easy. Any questions? No, I dropped out. I went to 3 lectures.
I would say I'm doing a software engineering course, and you explained it downside better than the people who've been paid to explain that to me. So thank you for that.
Then get your money back.
Freddie, I was just curious about, in your experience, the sort of longevity of sysadmin type code. So you mentioned earlier in jest about the need to continue to maintain code for PowerShell 2. So I wonder if we're actually in a situation now where sysadmin type code actually is going to be around for longer than other types of code. So the need to actually implement good design patterns is particularly important because there'll be many hands working on it for a long time, much longer than you probably ever predict the code would have been around or should be around.
Exactly. Now, anything I say here is just going to be flam because last week I was a plumber. But if you read the writings of other people, you will certainly see that we all meet at these meetups, okay? And I personally read the daily WTF, and you get all these horror stories about that app that sat in a corner for ages, and you understand that okay, consultants are actually literally paid to go and dig up this archaeology, and because it's still required, it's still in use. Okay, if something starts out useful, it may well continue to be useful. But very often there are these stories of the app, okay, it is needed, change is needed. And I don't know about you guys, but I think it's probably the case that a lot of code is bad. Isn't bad? Might work, but it's a bit of a pain to work with, okay? We don't all have the luxury of all the code being beautiful and pristine and stuff. And we know that we're still going to get asked to change it. And then there is a cost to changing it that's greater than the cost would be, because first you've got to track down through all this line of code, and the changes might have to happen in a whole bunch of different places that doesn't make any sense. So it takes longer to understand. You're trying to keep track of things, so you might not do such a good job. You get weird bugs that you weren't expecting because everything is kind of a bit tangled. So it takes longer to make the change. And all this increases the cost. Okay, sometimes you have to make the change. Sometimes you don't have a choice. If you're in banking, there might be new regulation. You might just have to do it anyway, even if it's a real pig to work with. And imagine a scenario where if the code was beautiful, it would take a week to make that change. But because the code's dirty, it takes 8 weeks, right? Then we are looking at business costs, and it becomes a question for the business, okay? Was it right to just be lax early and incur a greater cost now? It's not for you or I to categorically say. I know what I feel in my heart, okay? I want that code to be clean. But realistically, there is sysadmin code out there. There are advantages to making it cleaner, but it might not actually be something that a business would elect to with full knowledge of the relative costs.
Thank you.
Sometimes technical debt is a thing, and sometimes the business is just going to say, leave the technical debt.
Any more questions?
I'm free!
Thank you.